Our next objective, number 9, we're being asked to calculate the number of grams of an element contained in a specific amount of the compound. These are using percent compositions as conversion factors, again stressing it must involve dimensional analysis where every number has a unit and label. Our first question says to calculate the mass of carbon in 120 grams of propane. C3H8 is an organic hydrocarbon. The name is called propane. Let's begin with the number 120. The unit is a gram and the label C3H8. We need a conversion factor that cancels the grams of the compound C3H8 and brings me just the mass of the carbon. What we need is the part over whole, the percent by mass of carbon. Now in our formula, carbon with a weight of 12, I'm seeing 3 of those. 12 times 3 is 36. Hydrogen with an atomic weight of 1, but there's 8 of them, so its contribution is 8 more units. Carrying this up, it looks like 44 grams. And again, just taking molar mass, 12 times 3 plus 8 is 44. If carbon's percent by mass is 36 grams out of the 44 gram total, notice how grams of propane cancel and we've converted to grams of carbon. Part over whole times 120. So I'll hit, please do the same with me, 120 times 36 over 44. Out of the 120 grams, 98.1 of those grams are coming from carbon atoms. Number 2. Calculate the mass of hydrogen in 450 grams of ammonium sulfate. First thing we'll need to do is be able to write a formula so we can add up some weights. Ammonium is our positive polyatomic ion. Ammonium is NH4 plus 1. The last name we're looking for is sulfate, also a polyatomic ion. It's SO4 carrying a minus 2. Ammonium sulfate is the compound we'll write for. We have 450 grams of NH4 with a plus 1, sulfate who's a minus 2, so we'll need a parenthesis and distribute. NH4 taken twice, SO4, ammonium sulfate. Again, our conversion factor will need to cancel grams of our compound, so placed on the bottom will be the entire formula weight for ammonium sulfate, and on the top we want just hydrogen atoms, so we'll need part over the whole. Adding up the formula weight of ammonium sulfate. Well, nitrogen weighs 14 off the periodic table, but I'm counting 2 of them in this formula. That subscript is carried out through the entire parenthesis, so 14 times 2, plus hydrogen's atomic weight of 1, 4 times 2 gives me a total of 8 in the compound, plus sulfur's atomic weight of 32, and there's just 1 of them, so plus 32, and oxygen's atomic weight of 16, and I'm counting 4 altogether. So just all done on my calculator screen, I've added 2 N's, 8 H's, 1 sulfur, and 4 oxygens for a total formula weight of 132. Hydrogen's contribution was 8, part over whole times 450. So 450 times 8 over 132. Hit that with me and see if we get a common answer. I found 27.3 grams of hydrogen. And one more. We'll be asked to calculate the mass of iron in 250 grams of iron, Roman numeral 3, oxide. Iron 3 oxide. Iron lives right in the heartland of I wouldn't know your charge by where you're looking. Iron needs a Roman numeral, so I'm seeing it given to me as a +3 charge. Its last name is oxide. Oxide from group 6A carries a -2 charge, a +3 with a -2. 250 grams of iron with its +3, Oxide with its -2, crisscross, Fe2O3. We want to calculate for the iron out of the weight of the whole compound. Fe2O3 is iron 3 oxide's formula. So we'll need to do some work. Iron on our periodic table has a molar mass of 55.845. Let's keep that decimal, call it 55.8. But there's 2 of them in the formula, so double that for the top number, 111.6. We need to add the weight of 3 more oxygens to get the total formula weight of our compound, so plus 16 times 3 for the oxygen's contribution, and the whole compound would weigh 159.6. Part over whole times 250. And again, hit with me. We take the 250 times 111.6. Oops, there's a calculator here. 111.6. And divide that by 159.6. And we find 174.8 grams of iron 3. Of just the iron, not the compound. 174.8 grams of Fe. And there will be the A+ earned for objective number 9. Percent composition using percent as a conversion factor.